Alright, so we're going to do one together, finding all the zeros of the polynomial. We're going to have to find all of these zeros in a unique way. So we're not only going to use all of the different ways of factoring that we already know, but I'm going to show you another crazy pattern that you sometimes see. So I want you to see it at least once. Alright, so when we are finding the zeros of a polynomial, our goal is to factor it out as far as possible so that we can find all of the x values that would give us a 0 output. Okay, so what would happen if this whole function was set equal to 0? Here is your order that you should look for things to factor. First, look for greatest common factor. Look for any cubics to see if you can group. Look for any quadratics that you can either use the quadratic formula, that you can factor into binomials, or sometimes you already have a binomial with a quadratic and you can set it equal to 0. If none of those are true, you are forced to use your plus or minus p over q, also known as your rational roots theorem. So when we look at this, our leading term is x to the 5th. So what is the first form of factoring that we are forced to do? Okay, we have to use the rational roots theorem. So first term, last term. Your lead coefficient is 1. Your constant is 8. And using fundamental theorem of algebra, why do we care that it's x to the 5th? We need to find 5 zeros. That tells us how many solutions we should be able to factor completely out of this. All right, so using the rational roots theorem, make your list of plus or minus p over q. Okay, since our leading coefficient is 1, you should have a possible root list of positive and negative 1, positive negative 2, positive negative 4, positive negative 8. What do we do with that list? You test it. What do you test it with? Synthetic division. Right, go ahead, pause it, pause the video, test all of those out until you find a 0, and then hit the play button and I will show you the 0 that I found. Hopefully we both found the same 0 first. Alright, so hopefully you tested that whole list, and when you used positive 2, let's see, so x to the 5th. If you didn't, double check if there's placeholders. You see 5, 4, 3, 2, 1, 0, so you shouldn't need any. Negative 2, negative 4, positive 8, positive 4, negative 8. I like using the positive and negative signs so that I don't accidentally blend numbers together. You don't have to, but I just don't want my 1 and my 2 to be so close that I forget that it's not a 12, so I keep those. All right, bring that down. Multiply 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Combine those to get negative 4. 2 times negative 4, negative 8. That gives me a 0. 2 times 0 is 0. That gives me a 4. 2 times 4 is 8. And you should have found a 0, which is what we are looking for. See, find all the zeros. That's what we want. So you're going to take this 2. And we have x equals 2. That is a 0 that we have just found. What does our synthetic quotient represent? It represents the whole other factor. Right, so we were working with x to the 5th. Since we divided an x out, we are now left with 1 x to the 4th plus 0x cubed minus 4x squared plus 0x plus 4, and we're still looking for zeros. Right? If we eliminate our 0 terms, you are left with x to the 4th minus 4x squared plus 4. All right, so here's where a crazy pattern shows up. I'm going to show you something that you should already know. See if you could use that to factor this quartic polynomial. Okay, so here's something you should know. If I give you x squared minus 4x plus 4, how would you factor that? Two numbers that add to negative 4 and multiply to positive 4, you would do x minus 2 times x minus 2. Hey, look at what you have. When you have an x in the middle, you factor out x's individually. So look at your x to the 4th minus 4x squared plus 4. Compare those and see if you can factor that out. It actually has its own pattern, super similar. You can factor this to x squared minus 2 times x squared minus 2. Negative 2 and negative 2 add to negative 4, multiply to positive 4. X squared times x squared is x to the 4th. So your first two terms multiply to your first term. Your second two terms add to your b value, multiply to your c value. So what do we have? What do we call it when you have two pieces inside parentheses? Those are called binomials. Let's look at our list. Greatest common factors, nope. Cubic, no. Quadratic, yes. Right? We already factored into our binomials. So can we set those x squared binomials equal to 0? Absolutely. So x squared minus 2 equals 0. X squared minus 2 equals 0. I know it might feel silly because they're the same to set both of them equal to 0. But they represent 4 pieces of information. So we don't just set one equal to 0 and call it good. Both of those are unique pieces. They look the same. They actually represent more information than just one of them. So let's solve those. All right, so since I had an x squared on the left, I should end up with 2 solutions. So I have x equals root 2, x equals negative root 2. On the right side, you have x squared, so you should end up with how many solutions? 2. So solve that. How many total solutions have we found? So 1, 2, 3, 4, and back up here to the top. That first one, 5. How many did we want? 5. When you see them doubled, like positive x squared and negative x squared, it does not mean that there's only one of each. It literally means there are 2 of each. These are double solutions, which means on your graph, you will hit at that point. So you cross going down and you cross going up. It bounces off when you're on your graph. So you don't just have square root of 2 once, you have it twice, and both of those are solutions. So don't think that when you get them twice, you only have to accept one of them. You need both of them. Okay, so here's your last one. I am not doing this one with you at all, but I will give you your final solution that you should be looking for in the end. So your goal is to do this one and end up with these solutions. right? So it's to the 5th, so you should have 5 of them. These are the 5 you should end up with. So go ahead and practice with that one, and hopefully you can find those 5.